thanks for joining, everybody. We're going to talk about something super exciting today, electric panel upgrades. I'm a little bit nervous, so I have Baby Yoda up here, like making me feel a little bit better, because I'm in front of all you beautiful smiley faces and everything. A little bit about myself. I've been helping families go solar for just over 12 years now. Just about 2 years with Powur. My beautiful friend Jonathan Brunasso helped bring me into Powur, and it's been the most amazing, life-changing experience for me. It's absolutely wonderful. In my past, I spent about 7 years with Tesla, who at the time was Solar City. I was one of the first people there. Sunrun, Solar Max. I worked for a couple PACE lenders, as we call them. So when it comes to experience and understanding what happens in this industry and how to get a job from the beginning to the end, I'm pretty good and pretty familiar with what we got to do. Hi, Tom Cotter. I see you, buddy. Just in case you didn't know, you're there. All right. Oh, got a little clicker thingy here. All right. Oh, that's the wrong way. So that's the pointer. There we go. It's the big green button, everybody, if you didn't know. Sorry about that. So we're going to talk about electric panel upgrades. And why is this important? How is this going to help you sell better? Well, it may not help you sell better as far as close the sale, but it will help you to not lose a sale or to do something that's going to cost you potentially $3,000 to $4,000 to $5,000 in lost margin because you made a mistake later. Guys like Tom Cotter, John Brunasso, Chris Brunasso, Cynthia, they're all been doing this for a long time. So if you need to use a bathroom break, this might be the time to do it. But for those of you that might be newer to solar or have been wondering, how the heck do I open an electric panel and take a look at it and understand what's going on? You want to pay attention just because this will really help you sound like an expert, which will separate you from the competition, and it will help you make sure you're pricing a job right and you're not setting yourself up to fail. Personally, with Powur, I think I have about 65 or 70 installs so far, and there's only been one time that I messed up on an electric panel and I had to eat it on my margin a little bit. So first, we're going to talk about what is the main electrical panel. So it's the breaker panel that is where the power comes from the grid into your home. It's the first line of defense that helps protect homeowners and your appliances from damage and your house from potentially catching on fire. And then the panel distributes power from the grid to different parts of your home based on how much those parts are allowed to handle. How long do they last? One question that you'll see a lot, especially if you deal with parts of Southern California where I am, or Texas, from what I understand, where there's some older homes as well. How long can an electric panel be good for? Well, average is 25 to 40 years. A lot of times, I don't see panels get disqualified because they're old, unless there are certain kinds of panels, which we'll talk about a little bit later. So the main question that we care about is, do I need to upgrade my electric panel for solar? And what is that? So a main panel upgrade is a service where we basically change the existing breaker box to a new breaker box with new circuit breakers so that it can accommodate our solar system. Sometimes if the breakers aren't big enough to handle what we're doing, you're going to have to do one as well. We'll go over that a little bit later. And the majority of people, in my experience at least, probably 70% of people, your electric panel is going to be just fine. Part of it depends on your area, but for the most part, they're going to be okay. And sometimes there's workarounds where you're able to make it work as well. So generally, solar requires a 200 amp panel. And with everything in solar, guys, you got to remember it's partially geographic as well. So some of what we talk about might be a little different in Florida, or it might be a little bit different in Texas or North Carolina or different places like that. For example, in Texas and Florida, a big thing that they use to get around doing panel upgrades is something called a line side tap. In most parts of California, we can't do that. And it's unfortunate because it's awesome and it helps a lot. We used to be able to do it back in the day, but we can't do it now. So when you're seeing how big your breaker is, you want to look at that main breaker that you'll see on top of the panel. It's the top thing that's right here. See the little laser pointer guy. Normally you'll say 200 or something like that. And that'll help you determine the size of it. So the average electric panel that you're going to see is 100 amp, 200 amp, or if you really get into big homes, you'll see some 400 amp panels like them 6,000 square foot homes. I think the biggest one I saw was a 600 amp panel when I did a 50 kilowatt solar system for a 10,000 square foot home, which was super awesome, by the way, because you make some good money on big systems like that. But it's not just about knowing the main breaker size. Really more important is knowing the bus rating. And to do that, you need to look at the labels to see what that is. So what is the bus bar? What is the busing of a panel, as you'll hear it often called? It's easiest to think about it. You have the front of the panel, and then you have the back of the panel. So the front of the panel is that. It's where you see the breakers, you see the main breaker, you see the switches, you see different things like that. That's the front side. Well, that metal plate is called a faceplate. When we go do our site survey, they take that faceplate off to look at the back side of the panel, which is where the busing is. But so a couple other things that the busing is, it's basically a strip of metal that's on that back side of the panel. And the job of the front side of the panel is to make sure the back side of the panel doesn't get overloaded and it doesn't catch your house on fire. So if you have a 200 amp bus rating, like that last little example says at the bottom, the maximum flow through can be 200 amps. And that's kind of what the main breaker does in protecting the busing on the backside of it. So this is really, really key, everybody. If you're going to pay attention, this is one of the things you definitely need to pay attention to. Anytime you can see it, you want to look at the label. This is normally going to be on the door. If it's not on the door and there's not a label, we have to assume that the bus rating is the same as the main breaker. So if you see a 200 amp breaker and there's no label on the door, like that picture right there, or you don't see anything like that, we have to assume it's the same as the main breaker. It's just kind of how we do it. Specifically, what you're looking for is the word max. So sometimes you'll see a 200 amp breaker and you'll see it's a 200 amp max. Or sometimes you'll see a 150 amp breaker and you'll see 150 max. Sometimes you'll see a 100 amp breaker, but you'll see the word 125 amp max. That max is what you need to do your best to find. And again, when we're doing your math later, if you can't find that, you're just going to assume that the main breaker is the size of the busing as well. Does that make sense so far? Can I get hands? Does everybody get that right there? Thumbs up. Cool. Thank you, everybody. Hey, it's like got a couple hundred people waving at me. Appreciate that. All right. So why is this all important? What does it matter? Well, what we're trying to find out is how much solar we can backfeed to the grid. That's the key thing that we're trying to determine. So what is backfeeding? So normally, the grid feeds the house power. So we're pulling in power from the grid, and that's how we get our power. Well, solar, oftentimes, it's going to reverse that process, and you're going to backfeed the power to the grid or send it back to the grid. When they're doing that, they measure that power in amps. So when you're talking about backfeeding, they measure it in amps, just like your breaker. It'll say your breaker is a 200 amp breaker. Your busing is a 225 amp busing. So the word amp is what's important. They don't care about kilowatts and stuff like that. They care about how much amps are you feeding back. So the question is, how do you know how many amps you're feeding back? Well, you need to know what your inverter is doing, because your inverter, or in the case of Enphase, your micro inverter, that's what's feeding amps back to the grid. And that's how we learn That's how we find out the number that we need to calculate for feeding power back. SolarEdge is a centralized box. So that box is going to have an amperage that it feeds back. With Enphase, or these microinverters, each inverter has amps it's going to feed back. So you have to find out the total number of inverters, multiply the amp per inverter, and now you figure out your whole thing. So we'll see some of this laid out here in just a little bit. So the question is, you have to determine two things. How much backfeed is allowed, and how much backfeed do I need to determine if you need a panel upgrade or something along those lines. All right, so you're going to want to copy this slide, or later on when you're looking at it and you're trying to remember all this math stuff we went over, this is the one that we're starting with. So in order to determine our allowable backfeed, you take the bus rating, remember that's the number that's on the label, times 120%, and then you minus the main breaker size. So for example, if you have a 125 amp bus and you have a 100 amp main breaker, you do 125 amps times 120% minus 100 amps, because that's the main breaker size. So you have 150 minus 100, and that gives you 50 amps of allowable backfeed. So a real common misconception in solar is that if you have a 100 amp panel, it's not going to work. Well, in reality, if you have a 100 amp panel, but the label says 125 amp max, you're almost always golden. That's like my favorite thing to run into for the most part. Another math example, let's say that you have a 200 amp panel. So you have a 200 amp bus, so the label says 200 amp max. Then your main breaker is 200 amps. So it's 200 times 120% minus 200. So that's 240 minus 200 equals 40 amps of allowable backfeed. So if you have a 200 amp main panel and a 200 amp max bus rating, the max backfeed that you're going to get is 40 amps. Well, if you look at these two examples, you'll see that the 100 amp panel allows you to have a bigger solar system than a 200 amp panel. And a lot of people don't realize that, but that's where that math equation comes in from. So is everybody following so far? Can I see some hands? Is that okay? Do I need to tell a joke or anything like that? Let's see, a funny joke. What do you call a fish with no eyes? Fish. Get it? There's no eyes in F-I-S-H. Anyways, that's a joke. I got that from Ghostbusters. All right. So now that we know the allowable backfeed that you can have for that specific panel, you need to know how much backfeed your solar system is going to give you. All right, now, if the math starts to get jumbled, I apologize. I've been doing this for over 12 years now, so I've seen this a bazillion times, so I can kind of talk about it in my sleep. This is another one of the slides that you're going to want to save for later. Take a snapshot, or when you get them, you're going to see them and know what you got to do. So here at Powur, we use two types of inverters. We use Enphase microinverters, which gets my vote for being the best, by the way. And then we use SolarEdge. So with the math, normally with the panels that we have now, you're going to be using the IQ Plus inverter or the IQ7A inverter for the 400 amp panels, like beautiful REC panels that we have now. The bigger the inverter, the more amps it's going to give back. So again, the bigger the system, the bigger the amps that are going to have to go back to the grid. Does that make sense? Heads? Hands? That makes sense? Bigger system, more power? All right, cool. So per inverter, you're going to see the IQ Plus has a 1.512 backfeed So that's just for one inverter. If you have 20 inverters, you got to multiply that by 20. The Enphase IQ7A has 1.82 amps per inverter. That's because it's helping you get them bigger panels through them, 400 watt panels. SolarEdge is a little different, and they don't really have an easy spec sheet that I had access to. You're going to have to look at their spec sheet, and you're going to see the word maximum continual output. And if you take, the way that their things work is they give you each inverter type. It gets bigger as you go to the right. And then you have to take that continual output, and then you have to multiply that by 125%. Just take a picture of this sheet or keep it with you. You can look up SolarEdge's stuff at that website that's on there. It'll take you right to their spec sheet. So that'll help you more with the math. We're going to focus a little bit more on Enphase because it's a little bit easier to calculate for the examples that we're going to do. So here's some example math for you. Let's skip that one because we don't use that one all the time now. All right. So let's say that we need to use 32 Enphase IQ7 Plus inverters. All right. So each of those inverters has a backfeed of 1.512 amps. So in order to figure out how much you're going to need to backfeed, you're going to take 32 times 1.512. That equals 48.38 amps. Okay, so that's the total that you're pushing back. So if you have to push back 48, you need to make sure that your electric panel can accommodate 48 amps going back to it. Actually, 48.38. You cannot round down. So in this scenario, you'd really have to have 50 amps that your electric panel can accommodate because you couldn't do 48 because it doesn't pass electric code. Here's another example. Let's say that we have 12, let's go to this next one down here. Let's say that we have 26 Enphase IQ7A. So remember, those are for the 400 watt panels, or hopefully the 420s or the LG 440s that we have. So you have 26 inverters times 1.82 amps per inverter. So that equals 47.32 amps of backfeed that you're going to have. So that's how you have to make sure that your electric panel can accommodate that much backfeed. SolarEdge is a little different, and you can kind of steal this page if you want. Their website also has some help on how to figure that out. But the bigger the inverter, the more backfeed that you're gonna need on that as well. And you can go back to that spec sheet that I showed you earlier, or look it up on their website, and you'll be able to find that info out. All right, so we're gonna have a little breakout, and you're gonna put your high school math hats on, and you're gonna work through a problem together. That should just take you a couple minutes. So in your breakout, you're doing a 27 panel, 400 watt REC system with IQ7A inverters. That should say inverters, I messed that up. We have a 125 amp bus rating and a 100 amp main breaker rating. So the question is, do we need a panel upgrade? If you were to go to this home, you're sitting with Mr. Smith, and you say, you know what, Mr. Smith, I'm the expert. Let's go walk outside and let's look at your electrical box and see what you got going on here. So here's the math. So do we need the upgrade? And then what is the math? And go ahead and take about 4 or 5 minutes here, and I'll see you back in a few. Hey, everybody. Welcome back. Did you have to put your high school thinking caps on? Just checking. So just in case you guys didn't know, my kids got me this cup, and it says Yoda Best Daddy. Or, yeah, Yoda Best Dad. So if you were wondering, I'm the best dad for everybody. Anyhow, so can we get some numbers typed in, what people came up with? Oh, I'm sorry, someone said it hurt their brain. It's not that hard. You know what will really hurt? When you lose $3,000 because you didn't do it right the first time. Or you lose a job, which is really worse. So somebody put 49.14, no upgrade needed. That's good. That's what the math is right there. So just in case, you take 125, because that's the bus, times 120% minus 100, and you come up with 50 amps. When you do the math of 27 IQ7 plus inverters times 1.82, it comes up to about 49. So you're right below where you need to be to do an upgrade. So good job, everybody. That was super awesome. Now, our friends at Enphase, they try to make it a little simpler for us. And remember, you're going to get a PDF copy of all this. So I have this document printed out that I can use in the home with me. And it's just a quick, hey, if you have this panel set up, you can fit this many inverters on it. I talked to our Enphase people. They're working one up for the IQ7A and hopefully the IQ8, which is supposed to be super duper awesome in the future here. So what are some other things that might pop up where you have to say, hey, maybe we're going to have to do an upgrade here. Maybe the math is fine, but maybe something will come up. And it's important because this is construction. So a lot of times if you've ever done a construction project on your home, things happen. Things come up. You know, they dig open your flooring and they hit a pipe, you know, because nobody knew there was a pipe there. Or there's some load-bearing wall. You didn't know it was a load-bearing wall. Now you got to spend all this extra money to do it. People are familiar with construction on their homes. So always leave yourself a little bit of wiggle room. You know, Mr. Jones, the math works out. 99% of the time we're going to be fine. But I've been doing this for a minute, so I have seen some other things happen. We're going to open the panel on your wall. When we get here, we're going to make sure it's okay. Make sure there haven't been any fires or arcs in it. Make sure everything's up to code because the inspector can normally come check that stuff out. So some different ones to look at would be like if you see these old school push button ones or something called a Zinsco panel, which kind of goes sideways like that one on the bottom right here. Sometimes those are going to need an upgrade. One other thing that we need to talk about when doing a panel upgrade, so this is a brand new one. A lot of times we're going to use the best manufacturers that are there right now. There's a couple different things that you can bring up with your customer when you price it in. So a lot of times you'll go into it, you'll say, hey, I know you're going to need an upgrade. This is what it's going to cost. But there's a couple different things that can pop up that might make it cost a little bit more. Do we have to move it? Or is there a gas main line right there? Different things like that. One common fallacy. Do my breakers still trip? So sometimes you'll do an upgrade and someone will be like, cool, man, if I turn on my toaster, my TV turns off. Or when I turn on my hairdryer, everything pops off. A panel upgrade will not fix that. Okay? You are not making your electricity better. The reason those things are tripping is because there's too many amps going through the circuit, and that causes the breaker to trip. Normally, when we were replacing an electric panel, that puppy might be 30, 40 years old. Those breakers have been there for a minute, right? So they're not going to trip as easily. So you have more of a chance of catching your house on fire if you're running more current through an older panel. So you install this beautiful new panel that costs $2,500. They're like, yes, my problems are solved. And then as soon as they turn on their hairdryer, it trips and everything goes out. And then they're going to call Chris Brunasso and say, you lied to me, Chris Brunasso. And he's going to say, well, no, like Paul told me, I told you that this doesn't fix problems like that. They would need an electrician to come in and fix stuff like that. So a couple other things to look out for when doing a panel upgrade. And part of this is geographic. So I'm speaking from California, some other parts of the country where I've run into this stuff before. Where's the gas meter? A lot of places you need spacing or 3 feet of spacing. Where are shrubs and bushes and fences? I had to have a customer pull out this bush that she loved. She loved it because it hid all that ugly stuff and all that ugly pool equipment. And I was like, hey, we can't do it if you don't pull it out. One other thing that comes up, if you're upgrading for a 100 amp panel to a 200 amp panel, the service that comes in from the utility also has a number. So Oftentimes, it's a 200 amp service that's coming in. Literally, the cables coming in from the grid support 200 amps of power going to the house. Sometimes you'll find a scenario where I just ran into this in San Diego last year, where it was a 100 amp panel, and he had a 100 amp service line, and in order for San Diego Gas and Electric to come pull a new one, it was going to cost $6,000. And he said no. I was like, well, I can't blame you. Tom Cotter would have been able to sell that job, but I didn't, and I lost it. So it was unfortunate, but it is what it is. So those are a couple different things to look at. And again, you want to prep the customer and remind them, hey, I'm looking, your bush is a little close right there. Got your fence, or you like it? You want to change it? Different things like that. And sometimes we're going to have to move the panel too, depending on your jurisdiction. They might say, hey, you need to take that breaker box from there and move it 20 feet over that way. And there's cables and conduit and all that jazz. So that costs normally start at around $1,000 and then kind of go up from there. So here are some workarounds for panel upgrades. The most common one throughout the country is what's called a main breaker downsize or a D-rate. Okay, you got to make the math work. So if you have a 200 amp bus and a 200 amp panel, and you only have 40 amps of backfeed in that scenario, but your inverters are sending back 60 amps of backfeed, you need more allowable backfeed. So you can, step one, downsize your main breaker. So go from a 200 amp breaker to a 175 amp breaker. Problem solved. They got to do some load calculations to make sure that the house itself can accommodate that. So I don't bring that up. A lot of times, because it's only $700, I'll price it in if I think that it can be a way to do it, and we'll do that. That's number one. You can't do that on a 100 amp panel, though, only on a 200 amp panel. Number two, it's called overdriving an inverter. So basically, you put more power through the inverter than it was meant to accommodate. Sometimes that's good, sometimes that's bad. Your project manager and your designer will help you with stuff like that. A lot of other parts of the country, you can do something called a line side tap. Florida, Texas, big states that do line side taps, really cool. And literally, instead of tapping the solar into the front side of the panel where all the breakers are, they tie it around the back side of the panel to where the service is coming in from the grid. That's awesome. If you can do that, that's the coolest thing ever. In California, we lost the ability to do that 10 years ago for the most part, and it kind of sucks. But I was talking with Mike Patterson in Florida, awesome mentor, awesome rep, does batteries all day long. That's how they get around that in Florida a lot. It was really cool. So we're going to go through this stuff a little bit quicker because we're running out of time. But a D-rate is normally your number one option, cheapest option, get it done pretty quick. I explained what a line side tap was. And then when we get to Hawaii, this will be more prevalent. It's called a Hawaiian tie-in. I've never done it because I've never done solar in Hawaii, and I don't think we do solar there now too. All right, so now we're going to have another small breakout session with a little bit more math. So put those math thinking caps back on. And remember, everybody, I appreciate you paying attention. I know that this is boring. I know that this is high school math that's not awesome. But I will tell you, when you bust your butt to sell a job that you're going to make $4,000 on, and you find out you need a $3,000 panel upgrade, that's the worst. Because you don't want to call the customer and say, hey, your monthly payment's going up $30. Maybe they were only saving $30. You know, that's a hard conversation to have, and you don't want to eat that money either. So that's important. So we're going to set you guys up with another breakout room. Take a look at the question. You have 30 panels, Q-Cell 400, IQ7s, 200 amp main breaker, 200 amp bus rating. What's the math to see if it will work, and all these other questions right here. Are you coming up right now? All right, go ahead, have fun, challenge yourself. See you in a minute. One note to leave you guys on. So not only does leaving out panel upgrades mess up your income, it also messes up our power pipeline. We are an efficient machine, but if our project managers got to go chasing change orders and customers that have gone dark because we told them their costs are going up $3,000, that slows down everything. Of all the projects that have hiccups or things that are on hold right now, over 30% of them are due to panel upgrades. That's on top of re-roofs. That's on top of permitting issues, all that other stuff. It's the number one problem at Powur with just this right here. So hopefully you can share your knowledge, what you learn, and keep it in mind for next time. And thank you for your time.